So let us start with the other problem. So in the case of other problem, you can see that so that is your question is, that is what I can say, the x of 4 minus t into, that is what I can say your y of t. So let me erase it. Actually had written it just for practice. So let me erase it. So here just a second guys. Yes. Yes. So now my question is like x of 4 minus t into y of t. So what is my x of 4 minus t, which is equal to what? X of minus t plus 4. And in the case of x of minus t plus 4, so what is your resultant? T plus 4 is equal to 0. Your t is equal to minus 4. I told you that two things comes into existence, that is one is shifting and one is your reflection, right? So you can only see. So t plus 4 is what? T plus 4 is here what I can say, shifting process, and minus t is what? So minus t is a reflection process. So your shifting and reflection process comes into picture over here, and so therefore you can see that. So now after you shift the signal to minus 4 places, so you are going to get the resultant signal like this. So my resultant signal would be what? So my resultant signal would be, so what I can say, it would be like this. So let me draw that resultant. So my resultant starts from 5, 4, yes, 4, and this is 3, 2, 1, right? So this is minus 5, this one is minus 4, and this line is minus 3, and this line is minus 2, and this is minus 1. I'll just rewrite the given signal again. So just a second, I guess it got congested. So yes, yes, no, not congested. So take this and then draw it. Yes. So this is, once again I say, this is minus 5. So this is minus 4, and this is 3, minus 3, and what I can say, this is minus 2, and what I can say, this is minus 1, right? So this is what is the required signal. That is, you shift the original signal x of t to minus 4 places to the left, right? So that is how you can see the original signal over here. So in the case of original signal, you can see that that is your it is starting from minus 1. So when you shift minus 1 to 4 places to the left, so you get minus 5, and when you shift 3 to 4 places, you get it as minus 1. So that is what you got it over there, right? This one, right? So now what is that going to happen is, after when you start reflecting this particular signal, so this part will come to this side, and this part will come to this side, right? This part will come to this side, and this triangular part will come to this side. So that is what is a resultant like this. So when this part come to this side, so therefore what happens is, when this part will get shifted to this side, so what happens is, whatever the amplitude of minus 1 you had, so that will go to 7, that will take the place of 7 here. And then whatever the amplitude of, that is you had with respect to minus 4, it would be the same. And minus 4, that is this minus 4, you can see it is the same here. And this minus 1, what happens is, for this particular minus 1, it will take the place of what? It will take the place of 7. So when you go to shift this over here, it will take the place of minus 7. So I can show it to you clearly here once again. So this is what is that signal which is going to shift. So when you shift this particular flip to this side, so then this minus 1 will take the place of 7, and this 4 will remain the same, right? So that is what. And in your case of triangle, so when you flip this triangle to this side, that is, when you shift this whole triangle to this side, so what is that going to happen is this triangle had the place of, that is, this triangle is joined to -4, right? So this triangle will take the place of -4, and when you shift this line to this side, so it will take the place of what, that is -3, right? So like I'll show it you here. So see, I'll tell you that. So see here, this was the triangle that we wanted, right? So this triangle was joined to -4 in the required signal, right? So see here, it is joined to -4, you can see, right? This is joined to -4 here, right? So this will remain as the same, and then what is that going to happen is, whatever this one is present, if you shift to that side, so then what is that going to happen is, it will take the place of -3, right? Yes, so that is what is given over here, and I guess you got it right. Yes, this is what is the reflection process. So this particular was at 1, this particular was at 1, and what is that going to happen is, this particular was at 1, and when you shifted to this side, it took the place of -7, right? And this particular was at 5, and you reflected, so this is at 4 itself. So this particular line was at 5, this is was -5, and when you shifted it, it took the place of what, -3, right? So this is what is the reflection, and your y of t is remaining the same. And what is that going to happen is, you can see here that it is, so you can see here that it is what, it is just a 0, because here, from here to here, there is no signal, so it is completely 0. And now we can say that from here to here, that is, from here to here also there is no signal, and from here to here also there is no signal, so it's completely 0. So therefore I can say that this signal is completely 0. So for x of 4 minus t into y of t, your signal is completely 0, right? This is what is another problem that we had to do, and you have many other problems also, right? So let me see that problem. So see here, you can see that this is what is the problem with respect to that, and these kinds of problems, it is with respect to discrete signals. So I'll just make a small brief of this particular problem. So this is x of n minus 2 plus y of n plus 2. What is n minus 2? You get n is equal to 2. So that is right shift to 2 places, right? So here you get n plus 2 is equal to 0, n is equal to -2. So it is left shift to 2 places. So what you are going to do, you are going to take this x of n signal and y of n signal, and you are going to do first n. For x of n, you are going to do what, that is n is equal to 2, that is right shift to 2 places, and this is for, you have to do n is equal to -2, that is left shift to 2 places, and whatever the resultant you are going to get, so you are going to what, you are going to just add with the you are going to add it, right? Resultant, that is x of n minus 2 plus y of n plus 2, you get this particular resultant, right? So why I am not going to this problem in detail is because you know how to do a discrete time problem, wherein we have already done, and please do make sure that you follow the same and do this problem, because if one problem is done, the same way all the other problems will go on. So therefore that is why I thought of not explaining things in detail, because if you see one problem, the same kind of procedure, use it for other problem also with respect to discrete time, right? So that is why it is quite easier. Why to do all the problems, right? So you can easily do, by seeing one problem, you can easily do other problem. Therefore I thought of just explaining the question and then showing you the answer, right? Don't feel bad. Just like I have already shared the question with respect to discrete time, so please to go through that first and then try to solve this problem, because if you try to solve more and more problem on yourself, it would be better, right? It would be better. I've done almost all the problems that comes for your exam, and please do follow that, and if you find any other problem also, please to do without fail. Okay, so now here you can see that it is x of 2n. So what is x of 2n? Your x of 2n is tend to be what? It is a compressed signal. So you are going to divide all the time period by 2, right? So you get compressed version. What is n minus 4? N is equal to 4. That is, you are going to shift the y of t signal to 4 places to the right, right? So that is what you have to do, and this is for x of 2n. You are going to what? You are going to divide the signal by 2, and what is that resultant you are going to get would be the signal, and this one also y of n minus 4, what you're going to do, you're going to shift the y of n signal to 4 places to the right, and whatever the resultant you're going to get, you need to keep as it is, and you're going to add the both, and you get the resultant like this, right? You get the resultant like this, right? So now coming on to my next question. So this is multiplication problem, right? That was an addition problem. This is multiplication problem. That is n is equal to minus 2. We have already seen in that problem, right? What is n is equal to minus 2? Shifting the x of t signal to 2 places to the left, right? So this is y of n minus 2, that is shifting to the, what I can say, this is shifting the this one, that is your x y of n signal to the what I can say, 2 places to the right, right? So this is what you have to do, and then you are going to multiply the signal. What is multiplication? Just amplitude multiplication. Whatever amplitude you have, you have to multiply with it. And here why this is really easy is because you have got for some amplitude for each and every time period, and you need to check with, I have told you one logic, that you need to check with whether the time period is present or not. So if your time period, for example, in this case you have one time period called as 7. So if you consider a time period called 7, you need to check with the other signal, that whether in the other signal you have an amplitude of 7. Like for example, you have got a question to add or multiply two signals. So if you consider this question only, so in the case of x of 2n, you find that there is a time period of 7, we are having some amplitude of 2, right? And you need to check with the other signal, that is y of n minus 4 signal, that you also have an amplitude of 7 with the time period of 7 with amplitude 2. If you have that, then what is that going to happen is, for that time period, what you're going to do, you are just going to what I can say, add those or multiply those according to the given question, right? And here you need not to consider the fraction values. Here you're only going to consider the numerical values, right? And it is really easier if you have one time period here, and if you don't have that time period in another signal, while addition or multiplication, it is easier. So you don't need to consider that particular time period itself in the case of a resultant, right? So that is why, so these kinds of questions are easier, and please do try it without fail. And let us see in another problem here. So here this is what I can say, the question is x of, that is what I can say, 3n minus 1, right? So what is 3n minus 1? So what is your n minus 1 is your shifting, and 3n minus 1 is that is scaling process, and you get a compressed version of the signal. I'm sorry, and this is what is the resultant, right? Yes. And then coming on to this particular 2 minus 2n, what is 2 minus 2n? So you can take it as, so that is minus 2n plus 2, right? So first, what is your procedure you have to do? So that is, first you're going to do n plus 2. So what is n plus 2 here? N plus 2 is equal to 0. N is equal to, what I can say, my minus 2. Here n is equal to minus 2, and so therefore you need to first shift the that is your y of n signal. So first shift the y of n signal to, what I can say, your 2 places to the what I can say, 2 places to the left side, and then you're going to, what you're going to do, then you're going to divide the time period by 2, and then you're going to then you're going to reflect the signal. So here, as this minus, the reflection process comes into existence. You're going to do all this, right? You know how to do this. I've already done in the question itself, and this is what is that particular question. And see here, that's u of t question, what all we have done. So these kinds of question you have done. So please do make sure that you do this particular so go and check the particular video for the unit step signal. And here these kinds of question we all did it now, and here you can see that so these kinds of question, so this kind of question we have already done, right? So see here, you can see that. So see here, you have got a signal like this. So I've already told you, just substitute the value of n values are substituted, and then you are going to result in what n values are substituted, and after you substitute the value of n till 1 2 3 4, whatever the values you get for n is equal to 1, and n is equal to 2, and n is equal to 3, and n is equal to 4. So for those values, whatever the resultant signal you are going to get, resultant values you are going to get for n is equal to 0 1 2 3, so that one you need to consider, and you are going to construct a signal like this. So this is what is constructed signal. and then so here you can see that, so he has taken till 6 and we have taken the values till 6 and we have constructed the signal, right? So this is what is done, and then now here he has, what he has done is here, yes, what he has done is here is constructed this x of n minus 2 as well as this x of 3n minus 3, right? All these things he has constructed, and he has also constructed x of 3 minus n, that is equal to x of minus n plus 3, that also is constructed. So this is what is the question, and here you can see that, so please do make sure that you for these kinds of question you need to substitute the value of n till certain values, that is from 0 to 4 5 or some values, and you're going to construct the signal according to the values, that is for n is equal to 0 what value you have got, so for that particular value you are going to construct a signal, and for n is equal to 1 and for n is equal to 2, so and so on it continues. So you're going to construct the signal first, and for that signal you're going to do solve the given problem, right? Here signal construction comes into existence, right? Here is not given the signal, here is only given the equation, so therefore by seeing the equations only we are going to construct the signal, right? Yes, so this is what is the given question, and see here you can see next one. So that is with respect to memoryless concept. So this is with respect to memoryless concept, and here with respect to memoryless concept, so see here it is you can see here that, so this question is nx into n minus 1 plus 2 is not memoryless. Why? You can see here inside the bracket it is n minus 1. See, after I have told you many a times, even after substituting the value of n, if there is any simplification to be done, so see here substitute the value of n as 2. So if you, can you keep 2 minus 1? No. You know what is 2 minus 1? It is 1. You can write 1 inside the bracket, right? So this is what is, I say that they are memoryless systems. You can say directly. So here it is time invariant. It is not time invariant. Why? Because here you can see it is nx. So here you have another x wherein when y of n minus n naught comes into picture, for the 10 also is substitute n minus n naught. So you get like what? You get like it is what I can say the y of what I can say, I'm sorry, you get it as that is n minus n naught into that is n minus n naught, I'm sorry, it is n minus n naught. So what I can say minus 1, that is plus 2. So this is not the same as that is n x, I'm sorry, left it x. So that is nx of n minus n naught minus 1 plus 2. So that is why it is time variant system, right? See here I have already got it. So now here it is linear. No. It is not at all linear. So these kinds of system are not at all linear, because here it is plus 2 is present, and when you take your individual what I can say the transformation of x1 of n and x2 of n, you get, so that is nx1 of n minus 1 plus 2 and nx2 of n minus 1 plus 2, that has been given here. And when you take the whole transformation, so in the case of whole transformation your resultant would be like this. So this one and this two are not at all equal, so I say that it is what? It is my time, it's my non-linear system, right? Yes. So now coming on to causality. So it is causality because it's depending upon the past values and it's not depending upon future values. So in the case of memoryless only, you just check with 3 to 4 negative as well as positive values, so that there only you can come to a conclusion that whether the output is depending upon the future values or not. If it is depending upon future values, there only if you get to know, then you can simply write a statement considering only one substituted value, which, so that that value when you substitute and get the result, it should depend upon future value, right? Yes. So see here stability. So here in the case of stability, so you can see that it is so for a stability you have got an equation like this, so wherein this equation is an unbounded one, so therefore it is your unstable system, right? So now coming on to another question, this is x of sin t, right? So this is x of sin t. So this is x of sin t. So therefore here the question is sin t. I have already told a question with respect to sin t, right? In the case of sin t, when you substitute the value like sin of 2 or sine of 3, what you're going to do is you have to just check it with a calculator. You can use your calculator to check sine of 2, sine of 0, sine of 1, so and so, right? So therefore you can directly say that this system is not causal as well as memoryless system, right? When you substitute only, you get to know what is the resultant. So if this is depending upon the future value only, then you can say that it is causal or it's non-causal, but here it is not causal as well as not memoryless, right? So now coming on to linearity procedure. So in the case of linearity procedure, it is a linear system, right? See, you can see here it's a linear system. See, you can see here. So if you consider here a transformation, whole transformation of ax1 of t plus bx2 of t, you're going to get this particular resultant, right? That is ax1 of sin t plus bx2 of sin t, and the same resultant you get in the case of a transformation of x1 of t plus b transformation of x2 of t. So therefore this is what I say my system is linear. So now coming on to this particular question, right? Coming on to this particular question, that is your y of n is equal to x square of n minus 2. Directly you can say that there is n minus 2, wherein when you substitute the values of n, what is that going to happen is that, so you can't keep it as it is. Like when you substitute 2 for n, so it is 2 minus 2, you can't keep it like that. You can you know what is 2 minus 2, it is 0. So therefore it is depending upon the, what you can say, the past value. So if you take minus 2 minus 2, it is minus 4, which is depending upon the past value. So therefore it is not memoryless but causal, and here you can say that it is a non-linear system because it is a squaring system, right? I guess you got it. So now coming on to, see here, it is not a linear system, it is non-linear system. I told you, right, it's a squaring system, right? So here it's a squaring system wherein you get the resultant like this. So resultant is this only, but what is this particular? This particular is, you know, what is a plus b the whole square, that is a square plus b square plus a 2ab into b square, right? Yes. So your formula, a plus b the whole square is equal to a square plus b square plus 2ab into b square. So this is what is the formula. So that formula here substituted over here. You can keep it like this also, or you can do the simplification if you know a plus b the whole square formula, right? You can keep it like this only, because many of them might forget a plus b the whole square formula. So don't go up to that extent, keep it as it is like this given, right? So now we can see for the case of time invariant system. So you can see that the system is time invariant. Why? Because there is only one n present, so there is no other n present. So if you subtract with n minus n naught, so and if you substitute n with n minus n naught, you get both the same. So see here it is like you subtracted, that is what I can say, your x square of n minus n minus 2 minus n naught, and here also it is the same. So therefore you can say that this is a time invariant system, right? So now coming on to so this particular question, so let me check with respect to this particular question now itself, and I'll clarify without fail. So see, let me check with it. So just a second guys, sorry for the interruption. So I'll check with respect to this question right now, and I'll going to tell you about this, right? So see, let me check with OD. So what I can say, this is OD of, okay, so let me consider this as OD itself. So this is OD of, that is your x of t. So OD of x of t will be same like what? So will be same like your what I can say, your ln, that is natural logarithmic of x of t question, what we have done, no, the same kind, right? So this would become equal to linear system, as you all know. So OD of, this is OD of x1 of t plus bx2 of t that you get in the case of whole transformation. So here you can see that there is one term, that is OD. So you need to make sure that that OD gets multiplied to this ax1 of t as well as bx2 of t. See here, this is OD into x1 of t plus bx2 of t, right? This one you need to make sure that this OD gets multiplied to x1 of t plus bx2 of t. So therefore as this is getting multiplied to x1 of t plus bx2 of t, so you get a into OD of x1 of t plus b into OD of x2 of t, wherein you get the same in term of, that is the A transformation of x1 of t and B transformation of x2 of t. So therefore that is why you can say that it is what is my linear system. So in the case of time invariant system, you can see that it is a time invariant system only, because there is only one t associated. So therefore you can say that it is what I can say, it is my time here, but it is given here, it is not time invariant. So this is some OD something with respect to mathematical terminology. So therefore here he is considering that this OD of x1 of t is x1 of t, that is minus x1 of minus t by 2. So see here you can say that so this is, you can see that this is different. So see here there is a minus t that is associated, and for minus t I already told you that it is t plus, that is t naught, right? This is my minus t into t. What I can say, for minus t what you have to do is you are going to take, that is minus of, that is t plus t naught, right? So minus of t plus t naught you need to consider. You need not to directly write t plus t minus t plus t naught directly. You need to put it inside the bracket if you get minus t. So that is what he has done it. So therefore he got this particular. So therefore this is not time invariant, right? What is OD of x of t is that it is x1 of t, that is minus x1 of minus t by 2. So this is what is that. So therefore here you can see that these two are different. So therefore it is a time, what I can say, invariant system, right? So this is what is for today's lecture, and I hope we learned more and more questions on the basic operation of signal problem, as well as what I can say here, properties of system problems, right? So therefore this is what is for today's lecture. If I find many more problems, let us do that without fail, and thank you.